Well, I'm going to present the deep learning model for question analysis and question classification that we have proposed for a low resource language. Our case study here is Persian. And we tried to introduce a new data set for this language, a closed domain data set for question analysis. I would like to start with an introduction to the question answering systems first. Question answering systems, or QA systems, are designed to retrieve a short, accurate answer to the user's question. And we have many types of QA systems, but two of them which are relevant to this research are knowledge-based QA systems and IR-based QA systems. In knowledge-based systems, we are going to retrieve the answer to the user's query from structured knowledge bases like ontologies or even knowledge graphs. But for the IR-based question answering systems, we are going to retrieve the answer from unstructured sources. It could be open web data or domain-specific data. Here in the architecture of IR-based QA systems, we have question processing component at the very first, at the beginning, that we need to have the query formulation, and we need to process the question to understand what kind of answer we should expect from the machine at the end. And without this component, we couldn't proceed to the other components in the architecture that you can see. After having this component done, we can go through the documents and passage retrieval and answer extraction. So you can see that after processing the question, we have the necessary information to retrieve the relevant passages and documents and then extract the correct answer. We have many types of questions, like factoid questions or non-factoid questions, or it could be like open domain questions or closed domain questions. That in open domain questions, question answering systems, users are allowed to ask whatever they like in open domain, but in closed domain, the users are only allowed to ask questions within a specific domain. If we want to just summarize what we have done in this work, we have proposed the first Persian medical question dataset, a kind of closed domain dataset for Persian for question analysis. So as I said, our focus is on question processing, the very first component in IR-based QA systems. And then I would like to go through the novel hybrid deep neural network model that we have proposed for question analysis and question classification. And we are going to go through the publicly available data set, which is there for open domain question analysis, but we have amended that data set a little bit to make it more appropriate for this task. Unfortunately, for low resource languages, there are not too many related works, and we only found one, which is there for question classification and question analysis for open domain, not for closed domain. And it's based on combination of TF-IDF vectors and pre-trained word-to-vec. And they have used 3 different classifiers: SVM, LSTM, and MLP. So this is the only work that we are going to have as our baseline to compare our results with. Another challenge that we have in low resource languages is word embedding, how we are going to generate embedding vectors for these languages. So the very first option that we have is to use pre-trained word-to-vec model that we have for Persian. And the other one is to train the word embedding from scratch. During the time that we are training the whole deep learning model, we are able to train the word embedding and generate the embedding vectors as well. So this is the figure showing the proposed model in our work that you can see on the left-hand side. At the very beginning, we are having our embedding vectors, and then we have applied bidirectional LSTM to have the very first processing on the context of the question. And then we have applied an attention mechanism to assign a score to each of the outputs that we are getting from the bidirectional LSTM to enhance the contextual understanding of the question. And in the results that I can show you, that if we remove this a layer here, what will happen and how it affect performance. And after having a good enhanced understanding of the context of the question, we have applied convolutional layer as the final classifier to get the label for the question, to see what kind of question we are having. And then we are going to have the other components of our based question answering system. So here we are having hyperparameters that we have used for our experiments, that some of them are there in the next slides to show you the ablation study, because for preventing overfitting, we have utilized dropout, and you can see that the size of the filters that we are having for a convolution layer and the number of filters and other hyperparameters which are necessary for running the experiments are here. And you can see three different columns here. The first column is showing the open domain data set, or the values for the hyperparameters that we have applied for open domain, that I'm going to introduce data sets in the next slide. The second column is about the experiments that we have done for the new version of the open domain data set that I said we have amended the publicly available open domain data set to make it better. And then the third column is the medical domain, which is the closed domain question analysis that we have generated our data, generated the data set ourselves. So here we have a very brief description for the data sets. The first one, which is the publicly available one, is the UTQD, which is for open domain, and it has 1,175 Persian questions. And it's based on geotaxonomy. It has 8 coarse grain classes, and we have applied validation, tenfold cross-validation method for this data set. The second data set is the translation of the GUARD data set, which is for the medical domain, and we could translate it. We could translate 1,568 factored questions to have a kind of Persian closed domain data set. It has 13 coarse grain classes, and we have applied split validation for this data set. But why we chose to have medical domain as our closed domain? Because of its importance and because of its complexity. It's one of the most difficult closed domains that we can have in our question answering systems. And based on the number of research works that have been done for this domain, you can see that lots of attempts have been done recently for this domain, because it's very complex and it's very important, and it truly affects the people's life. So about the evaluation metrics that we have used for evaluating the performance of our model, I can say accuracy and F measure are the two, I can say, popular metrics for assessing the performance of the QA models and classification tasks that we are talking about it here. So as the very first result that I wanted to show you is that the average performance of our model on both open domain and closed domain, to see what kind of F score we are getting from this model for both of the open domain and closed domain. In average, that you can see we are having 82.54 as the F score. But if you want to go through more detail and just talk about the challenges that I have for that we faced for the Persian low resource language, we have embedding vectors and different dimensionality that we have applied for the embedding vectors that you can see. We have used pre-trained scapegram model, which is designed, which is the only pre-trained model for Persian now. And we have other dimensionalities for embedding vectors that you can see. We have started from I can say, short embedding vectors, and we increased it a lot to see how it's going to affect the performance overall. So you can see that for the open domain here for the UTQD, when we go through the 50 about the dimensionality of the embedding, we are getting a kind of a drop in our accuracy, and we couldn't even increase the embedding dimensionality to 100 and 120 because we had a huge drop in the accuracy. That's why I didn't include it here. But for the closed domain, which is on the medical domain for the UIMQC dataset, you can see that we are having a good performance when we are having the embedding dimensionality 100. So you can see different settings are required for both open domain and closed domain. So at the time that we are applying the same model in open domain, we need to change some settings and make it appropriate for the open domain or either closed domain. And about the performance of the model only on the open domain, on the UTQD dataset, you can see that with pre-trained skipgram here on the left, we are having 81 F-score. And when we are using the deep learning model itself to generate embedding vectors for us, we get a better F-score, 82.99, almost 83. And when we remove one of the categories in the open domain dataset, when we have amended the open domain dataset, because there is a kind of category which is a kind of duplicate category, we get a better performance here. So not all of the open domain datasets in lower source languages are appropriate for the experiments. So this is the reason that we have included this here, that not all of the publicly available datasets are good enough to be used for the experiments. And here we are having the closed domain performance for our model. Again, with the pre-trained skipgram model embeddings, we are getting almost 63 as the F-score. And when we ask the model itself to generate the embedding vectors for us, we are getting not very significant improvement here, 64. And when we want to just go and compare our results with the only baseline model that we have for Persian here, you can see that with the same setting with the split validation and with the tenfold cross validation, we have significant improvement. And also another advantage of our model is that we designed our model in a way that it could perform good on both open domain and closed domain. And you can see that when we are having split validation, we are having almost 5% improvement. And when we are having tenfold cross validation, a huge improvement has been occurred. And here we have a kind of ablation study to show each of the layers that we are having in our deep learning model, how they are affecting the model's performance. So if we remove the dropout layer, or if we remove the self-attention layer or the convolution layer, how it's going to affect the model's performance. So you can see that, for example, dropout is designed to prevent overfitting, and self-attention is designed to enhance the interpretability of the contextual information that we have retrieved, that we have extracted from the question. So you can see all of them together are giving us 88.74 performance accuracy. And if we remove one of those layers, it will cause a lower accuracy. So if we want to conclude everything, first of all, I'm going to repeat this, that we have tried to introduce the very first closed domain data set for question analysis in Persian. And we tried to design a deep learning model that could work good on both open domain and closed domain for question classification and question analysis. And the bigger goal that we had was to have a kind of model that could be applied to the other low resource languages as well, not only Persian. So in our future work, we are going to include other low resource languages to make sure that the model that we have designed is good enough to be applied to the other low resource languages like Persian. And also we can employ the data augmentation techniques to enhance the data set, the diversity of data set, and also the size of the data set, and improve the generalizability. And different techniques are there for preventing overfitting as well. In this research, we employed a dropout layer, but it could be a kind of regularization method. So I'm done with the presentation. So thank you very much for listening.